All right, welcome everybody. I hope you can hear me, and I hope you can also see under your skin Hiroshi Ishii, who's a professor at the Media Lab and is our guest for today. It is my greatest pleasure to introduce Hiroshi. He's the lead of the Tangible Media Group at the MIT Media Lab, and there are two big reasons why we invited Hiroshi to be the closing speaker of our distinguished HCI lecture series here at the University of Chicago. The first one is the easiest one to introduce. It's his impressive work and legacy that Hiroshi is leaving, both for the field of human-computer interaction, computer science, and as you'll see, a broader impact that crosses the art world and many other fields as well. Hiroshi's work has received so many recognitions that I would easily spend the whole 45 minutes with just my introduction. So I will not read all of his amazing achievements, otherwise it would really take that much time, but I'll just select a few of the things to give you a sense of how he has inspired both academia, but also beyond of academia, such as the art world, as I was saying. Hiroshi is recognized as the founder of the concept of tangible user interfaces. Many of you certainly have heard of this term, and this became a new genre of research in my field in human-computer interaction. His seminal paper, Tangible Bits from the Chi 95 with Brig Ulmer, is not only led to an amazing body of citations and inspiring all sorts of researchers, but even led to the creation of a new conference, the Tangible Embodied Interaction Conference, the TE conference in 2007. In addition to that, I've been at many places outside of the academic world where I heard and saw and felt the impact of Hiroshi's work. Most notably, his whole body of work was exhibited at the Ars Electronica Center in Linz, one of the most prestigious venues for contemporary art and electronic art in the world, and it stayed there in permanent exhibition from 2001 to 2003. Hiroshi's been awarded, of course, tenure as an institution in 2001, as elected in the Chi Academy in 2006, and most recently, he actually received a Lifetime Research Award at the SIG Chi, which is the premier venue for human-computer interaction. This is the sort of the greatest thing a research scientist in HCI can receive for his influential research contributions to human-computer interaction in the past quarter century. Now, I did promise that there were two reasons why I invited Hiroshi. This is the easiest one to explain. The second one is more personal, and I just want to tell you a little bit about that before I turn to Hiroshi. The second reason is somewhat personal in the sense that for as long as I can remember being a scientist and reading works and getting inspired by them, I was deeply motivated and inspired by Hiroshi's work, but also his words, the things that I read when I was younger on his papers. And I sincerely hope, and my colleagues that helped me curate the series as well, sincerely hope that you'll be equally inspired by the talk today, our closing talk of this series. And without further ado, I'd like to turn the microphone over to Hiroshi. And after that, please feel free to type your questions in the chat, both YouTube chat if you're watching over YouTube, or Zoom chat if you're here with us on Zoom. And I'll moderate the Q&A session with both Hiroshi and one of his students, Ken Nagagaki, and you can ask Hiroshi about his work. So without further ado, Hiroshi, thank you so much.
Thank you, Pedro. Can you hear me? Great. I really appreciate your very generous, wonderful introductions. I really enjoy meeting people, especially through Chi communities, HCI, also medias. I met so many people. They really helped me to shape the new stream of Thunderbirds. This is one of the greatest honors I received last year in Glasgow, 2019. That this became possible by many people, many colleagues, many students, alumni, and all the supporting people. So I really cannot stop thanking them enough. So I've been in many community, Chi, TI, WIS, CSCW, also SIGGRAPH, those important communities, and also Tangible Media Group and MIT Media, and also my former life before MIT, I was in NTT Human Interface Laboratories, also spent 1 year in University Controls. All the encounter with amazing people helped me to really come up many of the crazy ideas. So maybe among them, I really want to thank to my students who really believed the crazy vision, like tangible bits or radical atoms, then work together day and night to make it work, make it tell a story to convince other people. So their passion and their energy is a real driving force. Also, since 1989, I've been attending all the Chi conference, except for this year it was canceled, which was supposed to be Hawaii. But I met so many people, Bill Buxton, Marilyn Mantis, and also Douglas Engelbart in 1998. Also, you see a lot of important colleagues. Even recently, former students, Anna became professors, Lin Yao in CMU, and also Sean Former in Stanford. So those are really great pleasure that I could really grow in this ACM CCI community. Also, I was so lucky to meet the real heroes, which made a dynamic impact. Doug Engelbart is one of the best heroes. Also, my best friend, Mark Weiser, also late Professor Bill Mitchell. They made an infinite impact in my thinking. Also, Mario Tokoros, Alan Kay, and Nicholas, I talk a story later, but they made me possible to jump to MIT from Japan. Also, I met a lot of great people in these high communities. One of the reasons is Pedros, also Patrick Bowdish. They grabbed me to Berlin and now in University of Chicago, which I can't be thank enough. So today, I talk about three chunks. One is seamless media. Before MIT, I did a lot of work in the video-mediated remote collaboration, CSCW. Now, then Thunderbirds. After I moved to MIT, I started Thunderbird user interface research. Then in the past decade, I'm focused about a new vision called radical atoms. So I'd like to compress this 30 years of research into 1 hour. When I was in NTT in 1990s, the dream was information superhighways. They really want to make amazing broadband network, which now happens in the internet. But at that time, they believed different technology called BISDN. My mission was how to create new value of the real-time bidirectional video-mediated communication system, basically like a Zoom we are doing now. So 30 years ago, we invented the teamwork session. Teamwork session enables multiple people can talk together, but also sharing a screen, but sharing the information, not only the information in the computer screen, but also the physical space, like a desktop. Now you can see on the desktop, I have a piece of papers. Then I'm sharing this one with remote peoples. Also remote partners sharing the screen. Now we are mixing about the physical media and the digital media using very simple technology called half-translucent video overlays. Everything was done by hardware. Dragging a screen from left screen to right, shared screen, right side, you can immediately share the screen. It's very, very like a Zoom. The difference is translucent video overlay. So you can also mix physical media, body, hands, and the digital drawing and the physical drawing. So that is a 30 years old work called teamwork session. This is system called the ClearBoard to go beyond teamwork session. I didn't like a boundary, windows of talking heads and shared screen. So 1992, Minori Kobayashi and I co-invented the ClearBoard, which enabled people seamlessly talk through this device, but having no windows. So now you can see me talking through this drafting table. In the remote table, my partner can see myself, also my gaze moving. So you can clearly see my gaze, eye beam. It's more than eye contact. You can clearly see where you're looking at. This is very important cue, non-verbal cue for the communication, especially in my culture from Asia. So we developed ClearBoard 1 and ClearBoard 2, but the goal is seamless integration between interpersonal and the shared workspace to make a gaze awareness and a natural and smooth transition between these two spaces. So this is a ClearBoard in 1990. We mock up. This is a ClearBoard 0, real simple glass. Then this is a video drawing version, ClearBoard 1, which allow you to the gaze awareness through the distance. So through this system, we learned a lot because at that time in 90s, video conference or video mediated collaboration was a big topic in the CSW field. I learned so much from video draw, also collab system from Xerox PARC, and of course, Douglas Engelbart legendary demo of NLS. Those are all sorts of inspiration. 1994, Mario Tokoro, who used to be a professor at Keio University, got contact from Alan Kay, asking him to introduce whoever who is interested in doing the work about the CSW. So Mario introduced me to Alan Kay. Then Alan Kay invited me to the conference in 1994 in Vanguard Conference in Atlanta. So I gave a talk, and right after my talk, Alan Kay and Nicolas Negroponte, they was a board member, came to me asking me to come to MIT. And I said yes after 5 minutes thinking, the coffee break. So that's the reason I moved to from NTT to MIT in 1995. So, but one of the conditions of Nicolas of hiring me is reboot. Don't continue the work I've done before, like a CSCW, Clearboard, team actuation. You have to start something brand new. That's a luxury because life is very short. So I took his comment very seriously. Then I started tangible user interface research in MIT Media Lab. So fundamentally, to find a new direction, I have to really think very strategically. If anything incremental may not really allow me to survive. So I start thinking about what is the fundamental principle, the GUI, which was mainstream in 25 years ago, but still today it's mainstream. Then start thinking about orthogonal vector, tangible, direct manipulation, multi-user, special purpose. Then I've been searching for the blimp, which appear in the night or sky, thinking this like a vector is like a searchlight. Then I finally found the notion, concept of the make digital tangible. That's the beginning of tangible user interface. So I wanted to invent new tangible and embodied interaction that inspire and engage people. So this is early photos from my group, but always I have an abacus in my hands. So abacus is an important symbol to represent tangibit because all the digits is physically embodied as a mechanical beings you can touch and manipulate. Also, if you shake it, it becomes a musical instrument. If your kids become toy train, also you can scratch your back. So this is an affordance of simple mechanical toy like abacus that is lost in a black box, silicon chip, which refuses you to do any qualitative reasoning. So how to bring transparency, affordance of these physical artifacts back to digital human interaction is one of my dreams. So eyes are in charge, but hands are underemployed. This is a great phrase from Malcolm McCullough's book, Abstracting Craft. So I think how to bring hands into the equation is one of my key interests. Representation of knowledge, something important. I like astronomy. Auroral is a beautiful artifact made of the wood and the brass, but also important thing, there's an interface, handle, which is supposed to be grabbed by our hands and arms. So once you grab, then start rotating. All the movement of a solar system is completely in sync with the body, bone, muscle, neural system. So there's no ambiguity about the causality chain. Why Mars, Venus, or Jupiter go around the sun? Why four seasons exist? So this is something very important point of view. We care tangibility, aesthetics, also interactive, because I want to really engage people. I want to inspire people. So these are three important key criteria of my group. So 1997, Brick Alma, my first student, and I co-authored first paper called Thunderbirds. This is a vision paper, not a user study paper, not a system paper. It's a vision. So that it was almost rejected, on the verge of rejection. But I was so lucky because Mark Weiser, he's a father of EVComp, was a reviewer, and he rescued, also Jim Holland, UCSD professors, rescued my papers. And but more important things, I got amazing email from Mark Weiser later. Dear Hiroshi and Break, I recently had a chance to read your Kai 97 paper, Thunderbirds. Great work. In my opinion, this is the kind of work that will characterize the technological landscape in the 21st century. I do have a request. My request is that you help me to stop the spread of misunderstanding of EVComp based on simply on its name. He was really like a worried about misuse or lack of understanding of his EVComp vision. Then in the end, he said something amazing. Thunderbirds is very nice and maybe could serve as overall umbrellas, but then you might lose it as a name of your research project. I never thought that the Thunderbirds and the EVComp have the same common spirit or philosophy in the base. So that's something most exciting and enlightening message I received in my life. So this became my treasure. So in addition to EVComp, I got so many inspiration. Digital Desk, also dangling string, and also Marble answering machine, and Grasshopper UI, George Fitzmaurice, and me, and Bill Buxton did in University of Toronto. If you're interested, you can check all the ACM digital library. So Thunderbirds is simply physical embodiment of digital information and computation. So always to compare the main paradigm of the GUI is very important, but rather simple. GUI, intangible representation, pixel sound, then generic input device, mouse, keyboard, or touchscreen. Tangible user interface use physical materials as a representation of information, so that it's inviting you to grab touch control. So boundary between control and representation is blurred. So that's the fundamental difference of tangible UI. If you graphically represent this exploration, in the left side, you see the intangible GUI representation. On the right side, this tangible representation becomes also graspable controller. So this is a picture which summarizes my battle against the Pixel Empire in the past 25 years. So Thunderbirds try to embody information and the computation. And we have a lot of the early prototypes we created to communicate this vision, because the vision is so vague, so abstract, so that we need a very concrete instances. Among them, foreground and the background, or center and the periphery, is a very important framework that we developed together. And in the foreground, like me talking to you is a foreground task. I devote my 100% attention. But also at the periphery, I can still hear and see something going, being aware at the periphery, like the presence of people in the cafe or wind blowing in the outside. So foreground, metadesk, background, ambient rooms. We try to juxtapose, try to articulate how it's important to let information flow between foreground and the background, helping a smooth, natural transition. So let me show one example of the ambient media called pinwheels, winds of bits. So this pinwheel is spinning in a digital wind of solar wind, ionized particles flying from the sun to the earth, that's spinning these pinwheels based on data. You can still talking or typing email, but you feel the wind is blowing in the actual space. It doesn't distract your foreground job, but you can be aware. So that is one of the important goals. So today, PC, phone, always demanding your foreground attention. But ambient media always stay there, single purpose. Then you need to do just paying attention, just glancing at, like a clock on the wall. This is one of the models. Then our team had a spin-off company called Ambient Devices. They made an ambient orb that is customizable globe. You can put any meaning, but once it reach the threshold, it starts changing the color, which inform you. Now is a good time to leave office because traffic is going down or impending rain is coming. So you need to have an umbrella. So let me show the music bottles, one of the first tangible piece, which also exhibit in many museums. So these are simple glass bottles, empty bottles, but there's a musician in it, like a genie bottles. If you open it, you can release the music. It's a very fragile glass bottles. If you drop, it's broken. You can't reboot it. So this is one instance of a Thunderbirds, and but this is a very personal project. I have a dream to give a present to my mom, who used to wake up early to check weather forecast on TV. Instead of checking weather on TV, I want her to open this blue bottle. So today is a fine day. So this is a metaphor she knows because she cooked for me, opening soy sauce bottles millions of times. Once you open bottles, the flavors, smell of the soy sauce coming out like perfume bottles. But she passed away in 1998. So I created a music bottle as a tribute to my mom. Also next year, my dear friend, Mark Weiser, passed away. So I wrote a paper, Bottles, a Transparent Interface, as a tribute to Dr. Mark Weiser. So important things, principle. What's the design principle behind all these instances? So in the early stage, I was very afraid of shadow, of Darth Vader, or Empire, Pixel Empire. So I tried to stay away from pixel or screen. So everything's I/O coincident. Physical object, actuated, can be sensing, but also actuator. You can see that in touch, this is a device, you can communicate over distance. These rollers are connected by mathematical spring. If you rotate in one direction, you feel the force of other people. This is a curly bot. This is like a record and play. This is a robot which remember all the movement and the play again and again. And this is like a bit of Seymour Papert turtle graphics, physically embodied. Then top of all is a new robotics technology that you can assemble all the components from bottom-up way. But also there's a passive components, active components. Active components can remember all the movement and then play again and again. So all the thing common is everything physical, actuated, tangible, no graphical screen, but the direct manipulation allow people to control those kind of stuff. Also, we are very passionate about the surface. We really want to make a surface, tabletop, floor, or ceiling, or floor into interactive, like a interface to the digital world. So let me show the one example. This is a first PhD candidate, Dr. John Dokofras, who did this ARP system for his PhD thesis for urban planning. If you put the buildings, it casts a shadow. This is not the optical shadow, but the digital shadows. Every physical object have a digital model. Then we can compute the digital shadows. And also you can control the direction or inter-shadow issue by controlling the clock. So clock becomes an inverse input device to adjust the position of the sun. Also, you can change the material to bricks to glass, so you can see the reflection of light on the surface. Then also you can do wind simulations. So you can reposition the buildings. Then boundary condition change. Then that can be fed into Navier-Stokes equation running under the table. Then recompute. So you can really understand the issue of inter-shadow, wind flow problem, for example, or traffic of the people. So this can be done on the sense table. Also, we apply for the real design in the urban design study at MIT, School of Architecture Planning. So students are now designing and representing the idea using a combination of the paper drawing, physical model, and the computer simulation at one place. So that's something very important. Also, we apply this sense table technology to the very abstract computational models. ARP is something obvious, scaled model of physical world, but you can also apply for digital world. So James Patten created this sense table, but apply for the event-driven simulation like IP network design range, also system dynamics for supply chain visualizations. And then you can put the pack into the node because all these models have a 2D graph representation. Putting a physical pack in node, then let people control using 2 hands, or 6 hands of 3 people, they can simultaneously simulate. So we confirm that the tangible interface can also enhance the experience of the computation simulation, like event-driven simulation or system dynamics. Also, we love music. So this is a James Pratt and Ben Rich project called Audio Pad. Hope you can hear the sound of the music. Computer music is great. Electronic music, we love it. But often concert is boring because all the musicians playing, touching, notebook computer. From distance, you can tell, are they really playing or just pre-recorded everything or doing other stuff. So we created a graphical language, decompose what happened computationally. Then we use a pack, 2 hands or 4 hands, now 2 musicians interacting simultaneously. Then you can see this blue object. This blue object is a physical icon, represent microphone. So distance determines the volume of sound, but all the parameters is directly manipulatable. Then we can project this video to the wall or ceiling, like a video jockey does. So this is a new experiences. So our team exhibited in the NIME conference in Barcelona. Then Sergio Jorda's team got this idea to next level called React Table, which became a commercial product. I'm very proud of this evolution of this idea to the real world. We very like to change the surface of the architecture space to the interface between digital world and the physical world. So this is the first social media that my team designed in 1998 called the Ping Pong Plus, and putting 4 microphones under each table, listening ball hit sound, comparing the difference of time. We can do triangulations, but adding a lot of the visual effect, you can change the nature of zero-sum game into the very pleasurable stuff, even for the audience. And we developed variety of the mode, which also went to the SIGGRAPH, ICC, also Arceltica, Center Pompidou. And so we are also very fascinated about making things move. So that we made an array of the magnet, which firing in certain order, then you can make things move. Also in the center, you can see synchronization of 2 tables, one in Chicago, one in Boston. People are talking about optimal layout of a cellular phone tower. They can really discuss ideal position. But now you can see same tower is grabbed by 2 persons, separate persons. Then they feel the force, bit like an in-touch. Now interpersonal haptic communication channel open between the hands of 2 people. Also James Patton PhD thesis, PICO. This mechanical intervention. Now computer can express the computational results as a mechanical movement of the puck, but people can intervene, give a constraint about the movement. Now you can see the skirt, so they can't come closer than certain distance. Also, it's a bit like a more human relationship. You can also put a bit more sophisticated structure so that you can also constrain the range of the movement. Now, if you want to accelerate computation in certain area, you can use the material called dish soap. Then you can make a surface slippery so that the more computation resource can be devoted to this area of the computation. This is a new a genre which we call tangible computations. Also, we're interested about the 2.5D, how to go beyond 2D. So we are very interested about landscape design. We use a clay, also we use a sand. These are artistic exhibitions. Because sand is very malleable, people can really sculpt. Then you can see this vector. This vector shows water range, how the water run down. Color shows the speed, which indicates erosion. Also, how much sunlight each slope gets, so that what plants or trees can survive. So combining the beauty, aesthetics, form giving for the landscape, and also the computational analysis together is important essence of tangent bits. Also, we did a lot of the prototype, lot of paper submitted, many are rejected, but we still continue to work. So this is one of the pieces which became quite popular. This is Professor Kimiko Ryokai. She's now teaching at University of California, Berkeley. Her team invented the airbrush. We love painting, but in the era of Renaissance, painters were also color makers. They used to make their own pigment so that they can create real ideal color. So if you go to a market, you see the beautiful fruits, but that become a color palette. So you can't stop thinking, what kind of a new art piece you can create out of these pieces. So using technology, you can do a lot of stuff. You can add new function like a history. Now you can see teddy bear. From teddy bear, this color came from. So it can capture all the origin or history. So we went to the kindergartens and Kimiko told the kids, this is a history mode, but she doesn't care. She doesn't listen to us. She came up with her own interpretation, own idea of this medium. This is a very important moment as interaction designers. It's a real pleasure that the kids went beyond our imagination. So this is photos from Barcelona. You see all the beautiful palette of the color of natures, but these really making future artists get inspired. So if kids play with the airbrush, they may create a lot of beautiful artists being inspired what they saw in the real world. We care HCI, but also we care art, contemporary art, media art, electric art. So we exhibit in many museums. This is the ICC exhibition in year 2000. I show all the Thunderbird stuff in the early generations. But also we could bring this to Ars Electronicas. We had a chance to show 3 years Get in Touch exhibitions in the Ars Electronica centers. Now you see In Touch, bunch of the pieces. So this is a great opportunity to meet kids, philosophers, artists, journalists, or whoever. They have all the conversation, discussion that we learn so much from them. Radical atoms is the endeavor after the Thunderbirds. So the two materials on this world, one is frozen atoms, like plastic atoms, plastic, metal, glass, wood, all frozen, and intangible pixel. Now you are seeing my slide as a pixel, photons hitting a retina, but intangible. You can't grasp, you can't touch. So my dream is to create new materials called radical atoms. That's dynamic, physical, and computational. And that can transform and change properties driven by data and computation. This sounds really crazy, but actually really crazy. And of course, we are inspired many prior work, programmable matters, reconfigure robotics, also shape display like a Felix by Hiro Iwata. Those really inspired us. But maybe best thing that happened is Ars Electronicas. Gerfried Stocker, his director of Ars Electronica, took my vision, Radical Atoms, as a banner of entire media arts festival. 20,000 people come, and artists and the visitors, they talk about the future. So he gave a really great subtitle, The Alchemist Over Time. Let's become alchemists, invent new gold, new diamond, new materials for artistic expression, communication, and design. So then we brought all the pieces, classic piece, music models, also students, and inform, also biologic, I talk later. But the best part is sharing all the experience with students, meeting amazing people. Also, I met Pedros in Ars Electronica, seeing his amazing work. So these are pieces we exhibited over there. And so I think media arts is something very, very important home for us, as well as ASM Signal. So I can't thank enough all the lessons we learned from the Ars Electronica. So this is a summary I contribute in the Active Matter book, edited by Skylar Tibbetts. It's an evolution from static passive to active kinetic, or Thunderbirds to radical atoms. So I'd like to go very quickly overview. I can't go any details, but if you're interested, everything is published if paper were not rejected. Also videos is online. So this is the first stage of the IO continent. Then we went to the variety of the Thunderbirds, which I'd like to talk briefly. So Interaction Magazine, we did an article called Radical Atoms, in which we explained one of the speculative design called the perfect red. When I started the Radical Atoms, I have no idea how to implement. But in the Kai, you have to build, prototype, find the user, find the task, you have to test. Otherwise, paper never get accepted. But we couldn't really stop imagining. So this is a speculation. Because, shape memory alloy is very interesting because alloy remember the shape of the metal wire. If so, why clay cannot remember the shape of all the canonical form or past form they were shaped? Also, semantic interpretation of language, like a semantic cut, repeat, or loop. So basically, we try to challenge the CAD software, putting all the intelligence into the materials. Still, we don't know how to build this completely, but this is the vision driving me towards next level of radical atoms. So Thunderbirds evolved to the shape display and also variation of the variety of the system. So let me start from Ken Nakagaki's piece called Line Form and Chain Form. Ken is now most senior PhD candidate in Thunderbirds group, and he's finishing. But he was interested about 1D instead of 2.5D. How 1D can be transformed into 3D. Line form, snakish like a rope, can be very versatile shape changing a new interface. Also, he made a modular stuff called chain form. Now, every module have a sensor, display, you can reconfigure. So these are pieces which drive us research. Also, Ken presented the Hermit's latest his invention, mechanical shell for actuated robotic tools, using a swarm robots called Toyo, made by Sony, but he transformed into very playful, versatile, new type of the interactive expensive, putting a mechanical shell on around this swarm robots. Now you can see, I like a strand beast shell. This is an homage to Theo Jensen. This is a beautiful piece, but nothing but your imagination is stop this one. So I think it's really interesting to think about what you can do with new actuated Thunder medias. So hope you have a chance to check his Hermit work. Going back to the origin of the radical atoms, we really focus shape display. Daniel Reitzinger did this very project. So basically, we are doing a redefine the rendering. Rendering is not anymore just pixel, but also physical and digital synchronized. So we do two things: invent new representation, then invent new interaction. Now you see the shape display, new representation, but also you can see mid-air gesture or direct manipulation. This is a new interaction technique. So this is maybe most famous system called Inform. Sean Forman, now professor in Stanford. Also Daniel Reitzinger, he's now professor in University of Colorado Boulders, co-invented with all of us. Hope many of you have seen this video, because I'm now in Cambridge at my home, but I miss my colleagues in London, also Tokyo, Chicago, New York. Being here and there is our fundamental dream. We are so tired of stuck in a Zoom grid, but how to really extend their physical presence over distance is our dream. So now you can see that Daniel manipulating ball from distance. You can also use any new kind of artifact. Importance intermaterial interaction. This is a machine robot push the inert material. Also, you can do like a CAD design session, form giving over distance. Also, 3D printing is great, but it's a dead end. Once you print, it's frozen. But here you can see they are still alive. They are still computing to meet the condition. Also, this is shape changing based on the mathematical equations under the water, digital water. So this year is open door to the new dimension, but also a lot of the engineering work, making all the southern pin work in the harmony is not a simple task, but our team did all the effort to make our dream come true. And also we made a new versions for Cooper Hewitt Design Museum in 2014, which also traveled to Linz, Austria, ran 3 years, kind of half broken, but many people really experience telepresence, which is very, very exciting. Also, we always care about the artistic expression. So this is the homage to the Escher. We call the Escher mode. Now you can see the maze. Don't ask me why. This is the art. So combining a 2-3 inform engine, following a method of triptych in the art, we made a kinetic triptych called Transform, which we brought to Milan Design Week. Let me roll the video. The red ball represents frozen atoms, old generation of physical materials. White pins represent radical atoms, new generation of materials that we are creating, but they can dance together. Also, they respond to the energy of human being. So this is a transform. And we're very happy that recognize and all the key members and professors and all around the world. So that's the kind of most exciting part for me. So evolution continue also to the from the materials. We are doing more soft, more organic materials, which we created and also the presented in the many venues, art venue, and also the KAI, WIST, TI. And in the top left, you see NUI, pneumatic user interface, combination of elastic, non-elastic material can define how material changes shape. Second, top from left is jam sheet, GFAO's work, and jamming, changing a stiffness material radically. And biologic, aeromorph, I talk more later, also Syria. But we are interested about making all this material dance, programs, how to change the stiffness or shape, for example. And recently, Hiramura presented the Venus materials, also collaborated with Ken Nakaki and our team. This is the new use of the fluid materials and microfluidics. So now you can see simple self-explanatory materials by changing the form or applying the pressure. You can see the visual image of changing. So this is a new interesting soft material interface, which allow very direct, simple interaction without any batteries or computations. We learned so much from nature. So this is the materials called cilia. We learned from the hair. So Dr. GFAO invented a new technique to print 15 micron thin hair, which become nice mechanical adhesion materials like a Velcro, much stronger. Also analyzing the sound of touch, you can really detect, recognize speed, pressure, direction sensing. But also vibrating this base, you can really make this cilia as an actuator, inert object on top of this material can move. So this is another example. Pattern of the hair determines the movement of this material. So this can be also impact on design. Fur and the feather, how to simulate the nature, the feather is our dream. But now we can control computationally very precisely. So that became amazing fashion design materials. Erin Robertson and our team collaborated to design this garment. Then we visit it in the Cooper Hewitt Design Museum. Nature is full of the hydromorphic materials. So pine cone is one of the great examples. So Professor Lin Yao, now teaching at the CMU, did a seminal PhD thesis focusing about hygromorphic. So in the center, you can see the Bacillus subtrusionatus. This is a bacteria. So we decided to cultivate this bacteria to turn into the relative humidity sensor and actuator to control the ventilation of the garment the dancer is wearing. So concept is second skin. You can wear the new skin, which has a bacteria breathing. Then you see millions of bacteria living, working as a sensor of relative humidity change, and also the actuator to control the flap so that they can control the flow of the air. This is an image from atomic force microscope because we have to write a paper for science, not only KAI. So we need very rigorous data and the radio. Then also we have to build from scratch bioprinter to put accurate amount of the bacteria solution into the target textile. So now you see that bacteria is printed onto the target flaps of the garment the dancer wear. So we appreciate science, biology, but also physiology. So this is her heat map and a sweat map. This informs us to make a precise computer simulation model to calculate what is the ideal ventilation for her to perform best. Based on this simulation calculation, we send the data to the printer to print exact amount of the bacteria at the target place of the garment. So bio is a new interface. It wanted to go beyond the human-machine interface, but towards human living-machine interface with environment. So we really care how to communicate, not only inventing, but the communication is so important. To do so, we did an exhibition. These are biologic, moving in real time. These are real-time shape changing based on steam. These are bioprinters. And this is what nature gave us, is a bacteria. Also, we did a demo using a mannequin wire. You can blow the steam, then you can show the change. But it's not exciting, it's not inspiring. The most inspiring thing is the people and the art. We invited our friends from Boston Ballet Company. They dance. But she told me she feel the change of the airflow. She felt like she's dancing with bacteria. But you can't write Kai paper or science paper. This is art. So also it's great. We got so many awards, and Lin Yao is now in CMU. Leading a morphing matter group, publishing so many new cool papers, which I'm very proud of. So we have a dream. I want materials grow. Also, I want material dance. So one example is I want to make wicked dance. So Udayan Umapes team invented the programmable droplet. With electric technology, now we can really control the movement or dance of the liquid on the circuit very precisely. These are the very strong implications in the biochemical, pharmaceutical industry because they're dealing with the liquid using very, very special expensive machine. But I have a very different idea, the Bango hot palette. So Udaya and our team discussed about how about the palette which see the real world, then create the color palette. So now all the ink coming closer to help the artist, painter to paint the beautiful scenery. So also our dream is to fly, levitate. Anti-gravity is something very important dream. So generally, Remy Post and our team co-invented the Xenon. Xenon is a materials you can place in the air, then float. Second, the computer knows exact location. Third, computer can move it. So that become medium to connect people and the digital world or remote space. And of course, we love astronomy. So we apply for the solar system like a movement. The reason is many people accept constraints without asking question. So don't take it for granted. Why don't you ask why this constraint exists? Why we have to obey for the gravity? So defy gravity is fundamental spirit of our research. So we care two things, invent and inspire. Scientific invention, technical invention, great. But unless you inspire people, it doesn't make an impact. People don't remember. It doesn't make an influence. That's the reason we also put a lot of energy for the exhibition in addition to the scientific publication. So our motto is be artistic and analytic, be poetic and pragmatic. So arts and sciences are very important two fields, and especially intersection is something so critical. So let me show Dr. Xiao Xiao. She lived in the two worlds. She's a great pianist, also amazing computer science hacker. One day she saw her reflection on piano. So she thought, would it be nice that she can live in piano forever to play with her or her grandchildren? So now you can see piano key moving. It's a ghostly presence, actuated key. But the pianist is inside the piano. Also, music is not just sound, vibration of air. Even before she hits the first key, the music already started because her breathing, movement of her shoulder, everything part of the important art. So this is cute girl is my daughter Alisa, but now she play role of young Xiao Xiao. So young Xiao Xiao played this piano many years ago. Now Dr. Xiao Xiao, who graduated MIT, is now playing together with young Xiao Xiao. This dream came from intergenerational communication, especially people who deceased. If your grandma was computer pianist, we want her to coming back to the piano in living room, then play with grandchildren. So we speak all the language, science, technology, art design. But the important thing is keep looping this spiral, something very important. To coming up idea, concept, translate into the art world, science, technology, design, because each word has a different value system, different language, different vocabulary. But also I'm interested about the 3D. So right side, you see Peter Brueggel's Tower of Babel. So our dream is to keep going these spirals of art, design, science, technology, then go higher and higher. That's my dream. So today I talk about the seamless media and also the Thunderbirds and the radical atoms. These are all the efforts keep creating a new mountains. But important things. Alan Kay and several other people said its future is not to predict but to invent. We have to invent, then inspire, then people choose as a mainstream if we are lucky enough. And the to so vision is most important because technology get obsolete in 1 year, needs also disappear or change 10 years. But the real vision, like Doug Engelbart, collective intelligence, Ivan Sutherland, ultimate display, Mark Weiser, excess computing, keep shining the light to the long, long future. So envision, embody, inspire, the very important three things. To do so, art play a very critical role for envision and inspire. So hope you love art as well as science and technology and design. So let's strive to push the boundary by envisioning a future, embodying original ideas, and inspiring people around the world. So this is a special slide because this is for Pedro Lopez and the University of Chicago, young faculty, young students. These three driving force, I always tell to young people who live much longer than me, stand out, blaze a trail, build a mountain. The nail that pokes out gets hammered down. Stick out too far, then no hammer can reach you. This is very important for young people. Your idea was not understood, appreciated by anybody. Nobody listened to you, but you have to still believe it. This is one dimension, stick out. Second, my favorite poet, Kotaro Takamura, wrote a poem called There is no road laid out before me. I charged forward and the path emerged behind me. So my interpretation, run at full speed on the path not yet born. There's no finish lines or stopwatch here. So this is a develop a new path in 2 dimensions. This is for maybe PhD candidates. So this is for faculty candidates. Build a mountain, own mountain from the ground up, and then ultimately be the first explorer to conquer this new summit. So this is my impression when I got a job offer from Nicolas Negroponte. The reason I chose to come to MIT, it was a mountain so high that peak was beyond the clouds. There seems to be no path leading to the top. But I learned it was completely wrong. There's no such things like a mountain. It's an illusion. I soon realized there's no existing mountain to climb. I had to be the one to create a mountain from the ground up, to be the first to reach a peak. That's how I survived. So today, I really appreciate that Professor Pedro Lopez kindly invited me to give a 1 hour talk. So I have a plan to go different place soon, but perhaps all together. And I always thinking about the future 2200 because people living in this future after we are gone. So what do you want to pass on to those living in 2200? How do you want to be remembered? What do you want your legacy to be? That's a question I've been asking to myself every day. Also my colleagues, my friends. So 2200 is about the futures to which we are responsible for. Life has set end point, but the future is never ending. So we have to really keep thinking about never ending future. Technology we love and hate soon become obsolete, but the true vision is everlasting. So with 2200, I'd like to end my talk. Thank you very much for your kind attention.
Thank you so much, Hiroshi. Can you hear me?
Yes, I can hear you. Thank you.
Thank you. That was fantastic. Thank you so much. This is a really comprehensive and thorough view on the last decades of your work. Thank you so much for that.
Oh, my pleasure.
I would also like to invite Ken Nagagaki, who is also here with us. Ken is one of Hiroshi's students, and he's here, and he was involved in most of the work that actually you saw on your screens that relates to the last years of Hiroshi's lab. So feel free to also ask questions to Ken. He can chime in on his perspective on any questions you might have, but also we can make this a larger panel, which always makes things more interesting once we have more perspective. So I'd like to ask a question, maybe for both Hiroshi and Ken, and then I'll turn into many of the amazing questions we've been receiving on the chat and on YouTube. So my first question is, let's start with challenges. I think that's one of the most interesting things for me. What would you both say that it's the next challenge? It can be of any form. It could be a technical challenge. It could be a conceptual challenge that we need to overcome to realize this vision that sometimes is called programmable materials that you very well envision in Perfect Red. What we have to overcome as a field or as scientists?
Great. That's a really great question. But maybe one meta challenge is success. Success is very dangerous. Once you succeed anything, you get stuck. You find a comfort zone. You can become a queen or king of the small hill, not seeing the mountain hidden by the cloud. So success is very dangerous. Always you have to keep challenge. What's next? What's going? Then, Pedro, your question is very important. I gave a talk in WIST CSW joint panels October, but 30 years ago, as you saw, I did a telepresence, seamless telepresence. Now I really believe tangible telepresence, like in touch and inform, because Zoom, I can see you, I can hear you, but where you are means I cannot believe your existence. It could be fake, it could be emulation, it could be recorded one, because no tangible interaction. Even I don't feel you in a space. If we're in the same space, our heartbeat, breathing speed, naturally synchronized. So sense of the presence or presence of absence is the next big thing. I'm very excited. So Ken?
That's fantastic answer. Ken, what's your take?
First of all, thanks for inviting to this great panel and Q&A. I think there are lots of very interesting challenges. I also saw some question about like accessibility, for example, where it's really interesting because like, I think Hiroshi doesn't often talk about accessibility, but more about, sticking this vision into people's mind where from there, people can figure out the technical feasibility to go beyond it. So I think that's like, I'm kind of partly addressing the question. But there are like so many challenges of this technical capabilities for accessibility, but also like how, so lots of question we have is like, once these crazy material become part of our physical environment, that will also be a really scary thing for people where people can start to feel it can be harmful because the table never changes. So how we kind of like design the future of the environment in consideration with, some kind of like user experience design, or how to let people kind of like get used to this crazy environment is like very interesting challenges.
There's actually a couple of questions already, both from YouTube and from the Zoom attendees. I'll just read them out here for you, both of you, that I think touch on different aspects of this point, which I really like. So Alexander Binian on YouTube is asking, thank you so much for the talk. What are the most promising developments for general purpose tangible computing interfaces? How can tangible computing enter daily life? And then we have a couple of other questions that I think surround this daily life idea. So I'd like to hear, maybe starting with Hiroshi, how do you see more tangible computers actually entering our space? You were just saying that Zoom could be a particularly nice example if we could tangibly communicate with each other. What other spaces do we see that might be the first targets of a daily life tangible computer?
Okay, thank you for this really good question. The general purpose is an illusion, same as perfect or complete. We don't know all the purposes of all the people on this planet. I talk about ambient media, completely current general purpose iPhone, Android phone, or notebook computer is foreground, pixel-oriented, very narrow. So not a general purpose. When we eat or exercise, walk in the wood, these are all the important purpose, but they never support it. So first, we should forget the illusion of general purpose, like a complete or perfect covering. Then we should think about the spectrum. Our life is not confined in a smartphone screen. We still miss so many things, like a physicality, by confined in the Zoom stuff. So be critical and constructive. Tangible against general purpose, because we go to special purpose, because I have no idea how to make tangible general purpose, because general purpose is illusion. But the important thing is eliminating clay, sandscape, for landscape design, that makes sense. People played with sand or clay, soil, 1,000 years for landscape design. So for landscape design, I found ideal materials, integrating digital and physical. So it's a spectrum. You can draw, but we have so many things. There's no such things cover everything. That's illusion. Then you have to really decide which is more important than what and for whom. Then what is the best materials? So tangible is not general purpose, but sense table can support many general stuff, more like a closer GUI. But toppable is very, very special, more special. So it's like a relativity. So there's no simple, clean answers. Also making tangible general purpose is not right goal. Also criticizing tangible too special is not a good idea, because we have a Swiss Army knife. You may have a Swiss Army knife. But do you cook every evening using Swiss Army knife? No, we use a very different tools. That's a reality. So think about realities. Think about being humans. Then think about the illusion of general purpose. Then think about what the real purpose as a researcher or inventor. That's my answer.
I like that. Let me turn that around for Ken as well, because we do have a question that follows up on this one. This is from Yujia Tao. She's a master student in my lab, and she says, "Thank you for the talk. I'm curious that for tangible interfaces to be ubiquitously deployed in people's life." So again, this idea of daily tangibles. Do we see ways for tangibles to be more easily created by amateurs, people without technical background? Maybe this is for both Ken and Hiroshi. Are there ways to bringing other people into the making of tangibles?
That's a very good question for Ken.
Go Ken.
Ken, you take a...
Well, yeah, I think like combining with that general and specific purpose question, I think this can be answered in some way of my perspective, because that's part of what I'm kind of like exploring in my PhD thesis, where like definitely like the radical atoms vision like touch onto like bringing tangible to a little bit more general purpose by transforming reconfigurability. And I think one of the approach I'm taking in my research is how to combine this like robotic devices, almost like a general purpose machines, with giving a new smart material covered on top of this robotic devices that can like translate it. So I think there are very interesting like technical like solution to combine some kind of like different types of like hybrid architecture, basically like a modular architecture, where there's a core robotic or actuated device that can be extended by some almost like recyclable material or fabric 3D printed material, where you could like repurpose for other stuff as to adapt to versatile application, where these like 3D printer can be utilized to make this like recyclability. So I think there is some like interesting technical opportunity out there to kind of like tackle these challenges.
That's a really great answer. I have one that I'm passionate about. I'm happy that I didn't ask this one. So this one comes from Spencer, who's actually a name that I recognize from my class. Hi, Spencer. So Spencer says, thank you very much for the talk, Dr. Hiroshi. I love your work and your vision. Which project or direction of radical atoms do you think has the most potential to shape the future of how we interact with computers in our environment? Oh no, sorry. This is from Brendan. I wanted to ask another question. I'm sorry about that. Let me find Spencer's. Okay, there we go. Do you think the future of Spencer says the following, and I'm quoting now. I'm sorry that I quoted Brendan before. Brendan, we'll get to your question as well. So here we go, Hiroshi. From Spencer, he says, do you think the future of immersive computing will continue to rely on mixed media via AR or VR, or do you envision tangible interfaces will become advanced enough that these digital interfaces like VR won't be needed anymore? It's a great question because I've had this discussion with Hiroshi before.
Yes, I like this comment. And one of my former students pointed out ultimate VR and the perfect radical atoms are indistinguishable. That's ultimate, but we take a very different approach. But I take it. And also forwarding futures. I'm very interested about this sequence. Can you see my background slide?
Yeah, we see Inform.
This is something I already show you. And also I show these videos. But one thing I showed in the WIST and the CSCW opening panel is the future. Now people really tired of Zoom being trapped in the 2D screen. So they are asking about what is the next one. Of course, this takes a lot of time but I think I really dream in 100 years, 200 years, some near breakthrough of technology appears. Concept is there. Half-broken prototype already there. People experience, people get excited. So hope that will make a new driving force. Today, I don't know what technology is required, like a perfect rate, but this tweet really encouraged me. Future of Zoom is already here. That's my answer.
That's great. Thanks for asking also Brendan's question. Thank you. All right, let's turn a little bit to a sort of different part, which I think, Hiroshi, you also talked a lot about the motifs that inspire you and the approaches that you take on creativity. And so we have a couple of questions, especially these two that I'm going to pick on, one by Jasmine. Jasmine Liu, who's a PhD student in my group, she asks, hi, Hiroshi, thank you so much for an inspiring talk. You spoke a lot about art to develop vision, but it also seems a lot like science fiction. Do you think about your visions for the future as a form of science fiction, or do you find inspiration from science fiction sources?
Okay. That's another very interesting question because you separate art and sci-fi or chemistry or biology or design. So basically, the important thing, don't put a label. If you go to library, the tree of classification, like a science, technology, design, very artificial. But once you go to real branch, you get stuck. But everything interesting happen in the boundary between sea of bits and the land of the atoms, or when science art collide, or new domain like bioinformatics emerges. There's no single journal, no single conference. Kai is great, Kai is very broad, but basically don't worry about the label. And the most important thing is core ideas. For me, tangible, because many things intangible. Also, I care about the presence of absence, for example. So finding real core ideas. Then don't worry, is sci-fi or art, which is more important, which subject you should take. Once you really know what's your dream, your vision, then become magnet, intellectual magnet. All the disciplines or books or papers or YouTube video coming close to you, being attracted to your vision. Also people, like a biologic, linear, red, the crazy second skin. But we don't have any wet lab. But Dr. Wilmer in a chemical engineering PhD came to my group. Also, all the people came through being fascinated. Then accomplish amazing, not only paper, exhibition, then sharing all the award. It's really great. So don't worry, it's called labeled sci-fi or art or philosophy. But also you're great. You are in University of Chicago, aren't you? It's a university. You can learn anything. So don't major single stuff, don't major minor or double major. Also meet people. You saw in my presentation, I met so many amazing people. And many are already gone, but I inherited all many great genes from them in my body and the brain. And so hope you don't get stuck about the label, but find your dream and passion. Then create your new domain with your name.
That's a great message. I think that also covers a sub-question that Michelle Romani said, would ask you, Hiroshi, if you consider code an art form. I'm pretty sure you're going to say yes. And then we have a last question because we're running out of time. So I want to ask a couple of deeper questions. So we have one here from Zoe Liu, who is a master's student in our department, also in my group. And she says, "Thank you for the amazing talk, Professor Ishii. In the digital world, bits and pixels are so versatile that they can be reused and reconstructed to convey different information." So that's in the digital. Have you ever wondered how we can look at tangible media in a sustainable way? For instance, could we decompose tangible interfaces into radical atoms and reuse it? So I think it's coming from a sustainability angle as well.
Thank you for pointing out very important issues. And some people believe the 3D printer should be more faster, or laser beam printer should print more faster. Is faster better? Or I like handwriting. I'm a calligrapher. I draw all the stuff using my hands and the pens. Also, I like sculpting using clay. Which is better? Of course, there's different opinion, but often high-speed mass production creates more waste, or not thinking carefully, not thinking thoroughly. When photos was very expensive, the film, we have to really carefully choose the right moment because film is also expensive. Also, when I was a student, I was not so rich, so I have to really use every resource. So which is better? That's a very important question to ask. Also, the recycling, reusability is something important. But even whatever you invent, we trash the amazing stuff. Like you can see, here's a phone. People keep buying new one, even original one is usable because obsolescence is already imprinted in the design or capitalism. So much more deeper than technology, which I cannot solve, but we have to really think very seriously. Reusable module might be nice. In the software, many people excited about object-oriented programming. Oh, so many nice, beautiful modules. You can reuse it. But the reuse seldom happen because 10 years later, I don't understand this code. Or situation changes, condition dramatically change. Often they build from scratch. So that's interesting trend. So I think you pointed out very important things from basically sustainability, which also community has to think very seriously because also there's a great TI paper that so many tangible interface paper, so many prototypes, but most of the material is not reusable. Even reusable, nobody reuses it, trash it. Is it good or bad? Of course, advancement in science, we have to waste certain stuff. But what's the limitation? What's our responsibility? That's a really great question. Perhaps for next symposium, you may invite me.
That's an awesome question, indeed. I'm going to skip over a few questions because we're running out of time. So Zhu Peng and Dasha and Eric, I'll send the questions to Professor Hiroshi Ishii over email, and Alec too. But I want to ask one last question because I think we had the chance today to hear a lot about what you have done already, Hiroshi, and see your vision and working so far in the last decades. But I would also like to ask you more about the next steps? What are you working about, and what are you thinking about? In which direction is your work going at the moment?
I think that's great question. And one direction I'm very much interested in is because of necessity, and also my pre-MIT like work I've done, and let me make myself smaller. So I think sense of the presence is something most interesting topics for me to think about. Let me just come on. So can you see the slide? So I think presence is something very profound, and how to really go beyond current paradigms of the Zoom grid video conference that we implemented 30 years ago is one of the very interesting passions I have. And so I think a distancing is a very important word. It's a verb. You have to have a control to decide what's the distance appropriate. But now we are forced to keep 2 feet, 6 feet, or 2 meters, or forever distance, for example. So I think there are so many interesting research, like beyond being there, done by Jim Holland's. This is a very important vision, not emulating reality, but also interpersonal distance, great work, Edward T. Hall, proxemics. So I'm now very much interested about how to make a new generation of the proxemics theory to also give a control to users. Also, distance you want to take with me and I want to take you might be different, asymmetry. How to give a room of negotiation is something I'm thinking a lot. So this is some kind of direction we are thinking. So give me another 10 years, then I come back very interesting stuff to talk to you guys. Yeah.
We are really looking forward to having you back in 10 years or even sooner if you want. Thank you so much, Hiroshi. Thank you so much, Ken, as well, for being in the panel. It's been a pleasure to have you both. Please, if you still have questions that did not get answered, feel free to drop your email in the Zoom chat. I will email all these questions to Professor Hiroshi, and if he has the time, he might still come back to you. And now I'd like to close the session. Thank you all for attending. This was the last of our fall 2020 Distinguished HCI lecture series, and it was a huge pleasure to end with Professor Hiroshi Ishii from the MIT Media Lab as our last speaker. And we hope to have you here also to visit the university in person. Thank you, Hiroshi. Yeah.
So if anybody wants to continue the conversation, I put my Twitter address, also Facebook address. So you are more than welcome to contact me. I can't respond very quickly, but my intention is try to really communicate as many as people. If any of my message response can be a source of the energy or inspiration, that's really great, my pleasure. So now in the slide behind me, you can see that my Twitter address and the Facebook, or you can also send emails. And I hope I can also visit beautiful campus of University of Chicago in person to meet all of you guys. So please keep connected.
Absolutely. Thank you so much. And do connect to Hiroshi. Thank you so much for that kind offer. All right. Thank you so everyone.
Thank you.